Well, my friends, we are nearing the end of our third unit pertaining to circles, and now including spheres. So this is a practice test, so this will be a good summary of the topics in this third and final unit on circles and spheres. So let's see what we've learned in this unit. Find the indicated measure. Okay, area of a circle. We know that the formula for the area of a circle is pi r squared. We're given the radius, so that means the area is going to be pi times radius squared. You can just type that in your calculator. If you did the 8.2 squared, you would get 67.24. So if you needed an exact answer, it would be 67.24 pi. Alright, just keep the pi there. But probably we would go ahead and write a decimal this time. Alright, so that would be the exact answer. And of course, in decimal form, we could just multiply that by pi. And so we get 211.24. Whoa, that's terrible too. The terrible twos, man. Alright, what did I say? 211.24. And this is area, so we should talk about centimeters squared. Diameter. We're given the area, and this is the area of the whole circle, and we're supposed to find the diameter. Look, if I give you something, substitute it into the formula. So if I give you area, substitute it into the area formula. So we know that area, again, is pi r squared. So if I take this 802 and substitute it in right there, let's see what I get. Well, I get 802 is equal to pi r squared. So I just need to get that r by itself. So I could divide both sides by pi, like so. So that's going to leave me with, get this out of the way. So far, so that's going to leave me with r squared. So far that means r squared is equal to 802 over pi. This is not the last step, so do not make a decimal. Instead, we'll leave it just like that. We know that we need to take the square root of both sides to get r by itself. So we will just take the square root. And that is going to give us the radius. Okay? Whatever that is, we're going to have to double it, because don't forget we're looking for the diameter. So let's put this in the calculator. Square root of 802 over pi. So square root of 802 over pi gives us that. Alright, now remember that that is the radius, so I'm going to go times 2, and that will be the diameter. Alright, so this was like 15.98 was the radius, which means the diameter, we doubled it and we got 31.96. So that is the answer that we were looking for. And this is a length, so we will go with centimeters. Alright, let's look at number 2, my friends. Find the area of the shaded sector. Oh, look at that. Anytime you're trying to find a partial area, the area of a sector, you should be thinking, you know what, we need to do part over whole equals part over whole, like this. It's one of these situations. Okay, and of course we know that this side is degrees. And we know that this side is area. Okay, so we're doing part over whole degrees. When we're talking about degrees, the whole is always the same. It's always 360. When we're talking about partial degrees, sometimes the angle's in here, sometimes it's out here, but look for degrees. It should have the degree symbol on it. So the partial degrees are 50. Okay, so there's our part over whole degrees. Now over here we need partial area over the whole area. Okay, the area of the shaded sector. Well, this shaded sector is the partial area. So we don't know it. That's what we're trying to find. So we will need a variable. I like to use lowercase a for the smaller area. I like to use uppercase A when I'm dealing with the whole area. So we can't have any more variables. We already have one variable there. So I'm hoping that we can solve for this. Now, part over whole. So this should be the whole area, the area of the whole circle. So you know what? Let's just calculate that off to the side. The area of the whole circle should be pi r squared. Okay, that means the area of the circle should be pi times 8 squared. That means the area of the whole circle is 64 pi. So that is going to go right here, 64 pi. So partial area, that's what we're looking for, divided by the whole area, pi r squared, which turns out to be 64 pi. So this is the equation that we need to solve to find this partial area. So let's go on and solve it. I like to reduce this, which in this case will be kind of easy because those zeros will cancel each other out. Okay, so we need to cross multiply. So 36 times a. Let me just switch colors a little bit. Alright, so 36 times a, so that's going to be 36a equals, and then we have 5 times 64. It's 320. So don't forget the pi though, so 320 pi. Notice one thing, some kids will take this 8 and think that's going to go somewhere. Notice nowhere in this equation do you see 8. Okay, the radius will never show up as a single number in the numerator or the denominator. The 8 helped us find the area. Also notice I did not just double this and put 16 pi. Okay, that was the circumference. This is area now, so we have to square it. Anyways, back to the math. So I cross multiplied, so now I just need to get a by itself, so we're almost to the last step. And we will divide both sides by 36, like this. Kabam! Okay, so I'm just going to reduce this to get my exact answer. So 320 over 36. Let's do that. I'm curious if it will do it with the pi first. So 320 pi over 36. Let me try that first. Oh, a calculator does it all for me. So 80 pi over 9. So 80 pi over 9. So this would be the exact answer for this shaded area. And I neglected to give you any units, so I can't really show you that that would be something squared. I'll do better next time. Anyway, obviously if I want a decimal, I can just hit the toggle button. That's 27.93. Okay, or 27.93. Alright, so that's number 2. Number 3, find the area of the circle if the area of the shaded sector is 42 square centimeters. Again, as soon as I see that we are dealing with a sector, I know that I'm going to do part over whole equals part over whole. Let me start with the degrees. Here we're given degrees, partial degrees. So that's 60 over 360. Now, this 42, is this a partial area or the whole area? Well, this is the partial area. Look, I've got an arrow pointing right to this little slice, this sector. I even used a small a for you. to remind you that this is going to be the partial area, not the whole area. But if all that failed to let you know, look what we're supposed to find. Find the area of the circle. Alright, we're looking for the whole area, so we can't know it, so that must be the variable. I have recommended that you use capital A to represent the entire area. So don't put an X there, put a capital A. And we're going to reduce. Okay, so these zeros would cancel out. 6 goes into 36 6 times. So what I've really got here is 42 over A is equal to 1/6. I just reduced. Cross multiplying, A times 1 is just A. So then that just leaves 6 times 42. That's 252. This time I have units. We're still doing area, so that will be centimeters squared. Alrighty then. That's number 3. Number 4, find the area of the shaded sector. This looks very much like the last problem with one small twist that we have to watch out for. Alright, some kids fall for this, don't you fall for it. Tell me what I'm doing wrong. I need to do part over whole, so I'm going to do 80 over 360. What did I just do wrong? It's not going to be 80. Hopefully that's what you were saying to me just now. Why not 80? This 80 is the white area. Okay, we're supposed to be finding the shaded area. The 80, the sector here, is not shaded. So what do? How do I find the degrees that go the other way around? Okay, how do I find these degrees? I subtract from 360. So if I do 360 minus 80, I'm going to get 280. Okay, so that's what's left. So that means 280 degrees. That's this big angle over here. Alright, like that's the major arc. So that's what we're doing. So do not fall for that trap. So when we do part over whole, we're going to have to do 280 degrees over 360, not 80 over 360. Now let's just reduce this. 280 over 360. That's 7/9. Okay, that's a much nicer numbers to work with. In the meantime, over here, part over whole, we're supposed to be finding the area of the shaded sector. That is the partial area. That means we are looking for this, small a. That means we better be able to find large A. Okay, the area of the whole circle is pi r squared. You can do this part in your head. The radius is 10, so that's pi 10 squared. So that is 100 pi. Okay, so that is going to go right there, 100 pi. Okay, so I've still got that now. So I've got A over 100 pi. Time to cross multiply. 9 times A. Alright, so let's put it over here. 9 times A is 9A. And then 7 times 100, of course, is 700. Please don't leave off the pi. Some kids do that. So to finally get that A, I just need to divide by 9 on both sides. Okay, 700 is not divisible by 9. So as far as an exact answer, that is it. The area of the sector is 700 pi over 9. Okay, and this is centimeters, so this area will be centimeters squared. Okay, or in decimal form, 700 pi over 9. In decimal form, I toggle it, so it's 244.35. Alright, that is how you do number 4. Number 5, find the area of a circle. No, the area of a circle is 531 square meters. Find the radius. Look, if I give you something, substitute it into its formula. So here I'm giving you the area. Alright, the area is this. Area of a circle. So look, the formula for the area of a circle is area equals pi times the radius squared. So I should take this 531 and put it in for the area. So that gives me 531 is equal to pi times the radius squared. Alright, I'm just supposed to find the radius. So in this case, I just need to divide both sides by pi, like this. Okay, kabam! So far, alright, that tells me that the radius squared is equal to 531 over pi. Please do not make this a decimal yet. We are not at the end. Yeah, leave it like that. To unsquare this, we need to take the square root of both sides, like this. Okay, now that is going to give me my radius. So look, as an exact answer, this is it. Alright, so my exact answer would be 530, square root of 531 over pi. You could feel free to put this right on your test, just like that. And this is going to be meters, because this is now a length. Meters. Or you could convert this to a decimal, square root of 531 over pi. So square root of 531 over pi. As a decimal, that's 13.000, well, 001. So that would round to 13.00 meters. Okay, so I would accept either one of these if this were a test, exact decimal. Alright, how about number 6? Find the diameter of circle S if the area of the shaded sector is 50.26. So, look, if I give you something, substitute it in. Wait, no, I guess we can't do that because there's no formula for the area of the shaded sector. What I meant to say was, just like on these problems up here, we just did 2 problems that involved a shaded sector. What do I do as soon as I see a shaded sector? Shaded sector. I immediately realize it's going to be part over whole equals part over whole. Didn't we have 3 of these, in fact? Yes, every time we see a shaded sector, we start doing part over whole equals part over whole. And this will be no exception. Shaded sector, okay, let's start doing part over whole equals part over whole. So, as I go to set this up, do I have the partial degrees? Yes, it's 100. Look, it's even in the shaded area like we want it. Total degrees, that's 360. Now, what about this over here? This should be area, partial area, total area. Well, look at this right here. This 50.26, that is the partial area. It is the area of the shaded sector. It even says so right here. So that's why this is going to go up here, because it is the partial area, and we're doing part over whole. The whole area, find the diameter. Well, fine, the whole area is not what we're looking for, but it's all we got right now. So we're going to have to find the whole area and then figure out a way to how to get the diameter out of it later. This is a perfect time to make sure you're using capital letter A down here. Do not put X down here, please. If you put an X down here, you're going to think that you're finished. When you find X, you're going to think you're done. And you won't be done, because what you'll really have is the area, and you're supposed to find the diameter. So, I like to reduce this, so let's just, respect. So 100 over 360. So 100 over 360. 5 over 18 people. So I've got 50.26 over area is equal to 5 over 18. Time to cross multiply. Hey. 5 times A. Maybe I'll do it down here. So 5 times A is just 5A. Now 18 times 50.26. 18 times 50.26. 904.68. It's 904.68. Alright, I need to get the area by itself, so I'm going to divide both sides by 5. Just going to squeeze that in. Okay, so that is going to give me the area. So this divided by 5. That's already in my calculator, so I can just go ahead and hit divided by 5 right now. If I were you, I would just keep all of these numbers. I know it's 3 decimals, but that's not impossible. So just write them down. 180.936. Okay. So far I've done no rounding. So I try not to round until the last step. So no rounding. So that's my area. But I am supposed to find the diameter. So if I have the area, I could substitute that into the area formula. The area of a circle, of course, is pi times the radius squared. So if I take this and put it in for A, then this is going to become, let me just save my space properly. This is going to become 180.936 equals pi r squared. This will help me find the radius, but then I'll have to double it. Okay, so let's see what we have. Okay, so I will definitely have to divide by pi. So those will cancel out. Alright, then I'm going to have to take the square root. To save space, I'm just going to show that these canceled out. So now I've got this. So now I need to take the square root of both sides to get r by itself. So that's going to look like this. Alright, take the square root of both sides. So that's going to give me the radius. Am I doing blue? Okay, so let's do that. Let's take the square root of all of that. Square root of 180.936. Okay, so the square root of 180.936 over pi, that gives me 7.58 blah blah blah. I'm saying blah 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 because I'm not actually going to round this either, because I know that what I really want is the diameter. So to get from the radius to the diameter, I need to double it. Okay, so I'm going to keep all these decimals. I haven't rounded yet, so I know I need to double it. I'm just going to hit times 2 like that. So this is my answer, and this is the first time I'm doing any rounding at all. So that's 15.18. Should be what everybody has. 15.18. Never round until the last step, just like I did. So that's the diameter. That's what we were looking for. And that should be meters. So that is your final answer. Okie Spinokie. Let's see. Number 7. Alright, man, for some reason kids have so much trouble. You know what? I should stop the video and split this into 2 parts, because this is already 25 minutes long. Alright. That is going to be the end of part 1. You know, that's like page 1. I am going to make a second video for page 2. So, if you need to see what happens on number 7, go ahead and watch the next video.